Panama Canal is one of the world's most important waterways, handling some 5% of all global trade. It links the Atlantic and Pacific Oceans by cutting through Panama in Central America. This shortcut has made the world smaller, and Panama quite a bit smaller. The canal has been operating at capacity for some time, and has been going through a $5.25 billion expansion program since 2007. These are the largest works on the waterway since its original construction, and have created some 30,000 jobs. It involves the deepening of channels at the Atlantic and Pacific entrances, the deepening of shipping lanes in the Calubra Cut and Gutan Lake, the raising of Gutan Lake's maximum operating level, and at the core, the $3.2 billion third set of locks project. This is one of the world's largest civil engineering schemes. When completed in 2016, and after a staggering 4.4 million cubic metres of concrete have been poured, the new locks will be 40% longer and 60% wider than the original locks, and allow the waterway to eventually double its shipping capacity. The design is required to withstand major earthquakes. The project has advanced seismic design state of practice, and the lock gates alone contain some 50,000 tonnes of steel. Panama Canal's expansion is one of the first large-scale civil engineering projects to use BIM, and it really has benefited each stage of the process. The project team is formed of a number of leading contractors and consultants from around the world. MWH Global lead the design process under a joint venture. At tender stage, MWH modelled several different design options and produced visualisations which helped the client understand the proposals and enabled them to take more informed decisions. The scale of this project means that MWH are collaborating with design teams in 5 different offices around the world and working on numerous elements simultaneously. The use of information models, hosted in an accessible online common data environment, has allowed this diverse team of engineers to better collaborate and better coordinate their information. Combining design information models in this way has helped to resolve design conflicts and discrepancies before construction, saving time and money. Purely on the graphical side, the 3D models have given the team powerful insight into the large and highly complex designs. Despite these design phase advantages, BIM adoption at Panama Canal hasn't been entirely wholesale, largely because of the project's length. The period between 2007 and 2016 has seen BIM steadily become developed and understood around the world. Standards and technology have been moving on, and the project team have been learning, along with the rest of us. Whilst the designers have worked within a BIM environment, construction issue information was extracted and presented to the contractors in a more conventional way, largely to meet the demands of the programme. In graphical terms, that meant 2D drawings cut from the 3D models. This is quite common for those that started their BIM journey and is all part of taking those first steps. But to see ultimate value, everyone needs to be working in the same way. The design team would have liked to link structural and hydraulic intelligence analysis into their models and are keen to do so on future civil engineering projects. Unfortunately, it proved a step too far at Panama. The information models have had their uses beyond the design team. The data has enabled some rough takeoffs for the purposes of estimating, and the 3D representations have helped contractors really visualise and understand proposals. The complex layouts for the mechanical and electrical installations, for example, were visually presented, helping contractors understand what was happening quickly and efficiently. The Panama team want to link the work they're doing in asset creation with asset management. They're using BIM workflows to capture asset information for the end user and physically tagging elements with ID tags for inclusion in the master maintenance manual. These unique ID tags are like barcodes, enabling users to scan elements of the locks in the field and be presented with the digital data that relates to them. The delivery phase is actually relatively short when you consider the life of the canal, which will span many decades. By ensuring that the rich data collated during design and construction can support the end user's facilities management approach, the canal will be able to operate with enhanced efficiency over time. The users will truly understand their asset and how it works, optimising its use. When you consider the importance of the Panama Canal to global trade, that optimal use really could benefit us all. MWH believes they made a significant step forward in their design process by adopting BIM at Panama and are already applying their learning to other major infrastructure projects. Indeed, both the timing and scale of Panama's canal expansion have placed it on the leading edge of case studies for BIM and infrastructure. If you enjoyed this video, please share it with a friend, and to get more like this, subscribe to the B1M.